From the shocking rise in fuel prices to our increasing reliance on electricity, many of us face the dilemma of how to cope with soaring bills this winter. But is there an alternative way to heat our homes that escapes these costs? Let's take inspiration from an ancient practice, a technique used by the Amish for centuries: wood-burning stoves. Without relying on gas or electricity, how do they manage to keep their homes warm? It's crucial to explore whether any of these traditional methods can be applied to our modern homes. Let's delve into these ancestral techniques to discover their secrets. Wood-burning stoves are essential in Amish homes, primarily due to their efficiency in heating large spaces economically and their ability to operate without relying on electricity. This is especially relevant for the Amish community, which maintains a lifestyle without connection to the modern power grid as part of their philosophy of self-sufficiency and detachment from contemporary technology. Furthermore, the use of wood-burning stoves not only has a functional purpose, but also a cultural component that connects the community with practices passed down from generation to generation. Wood-burning stoves provide constant and cozy warmth during the cold winter months, which is essential in the regions where many Amish communities reside, such as Ohio, Pennsylvania, and Indiana, where temperatures can drop considerably. This heating system also stands out for its sustainability, since wood, well managed, is a renewable energy source. Compared to gas or electricity, burning wood can have a lower carbon footprint, as long as responsible forest management is ensured. In addition, the wood-burning stoves used by the Amish are designed to be highly efficient. Many of them include secondary combustion systems, which allow gases and particles that would otherwise be released through the chimney to be burned, thus maximizing energy efficiency. This design ensures that the calorific power of the wood is used to the maximum, minimizing waste and the need to constantly replenish the fire. Proper maintenance of these stoves is also essential for safety and efficiency. The Amish make sure to clean the chimneys periodically to prevent the accumulation of creosote, a highly flammable substance. The preparation of firewood is an essential process that takes place during the warmer months of the year. The Amish dedicate much of the summer and fall to cutting, splitting, and storing firewood, ensuring that it is properly dried before use. Wet wood is inefficient, as it produces less heat and generates more smoke, which can be detrimental to both health and stove maintenance. Firewood must be dried for at least 6 months to reduce its moisture content to an optimal level, generally below 20%. To do this, the Amish usually meticulously stack the firewood, making sure that it is exposed to the wind and sun to accelerate the drying process. The selection of the type of wood is also important. The Amish often prefer hardwoods such as oak, maple, or walnut, which have a higher calorific value and produce a long-lasting fire. Softwoods, such as pine, although easier to cut, burn quickly and generate more creosote, which can result in an increased risk of chimney fire. The ability to select, cut, and store the right firewood is a fundamental part of the practical knowledge that the Amish pass down from generation to generation. Operating a wood stove effectively requires a number of specific skills, including adjusting the airflow to regulate combustion. Modern stoves often have multiple dampers or vents that allow you to control the amount of oxygen entering the combustion chamber. Knowing when to open or close these vents is crucial to maintaining efficient burning. Too much air intake can cause the wood to burn too quickly, while too little air will result in incomplete combustion, generating more smoke and waste. Supplemental heating with kerosene and oil lamps. During the coldest months, the Amish turn to the use of kerosene and oil lamps as supplemental heat sources. These lamps not only provide light, but also emit a considerable amount of heat that helps keep the most frequented spaces in the house warm, especially those where most daily activities are carried out, such as the kitchen or dining room. Kerosene lamps, by having a live flame, act as small sources of radiant heat, which are particularly effective in providing warmth in localized areas. The Amish prefer these lamps because of their simplicity and effectiveness. In addition to aligning with their refusal to rely on modern electricity, kerosene and oil are relatively accessible and easy to store fuels, allowing Amish families to maintain a degree of autonomy during the winter. This heating approach is particularly useful in large homes or buildings that lack centralized heating systems. Often, the lamps are strategically placed near areas where families gather, such as reading or handiwork areas, which maximizes their efficiency. In a broader context, the use of kerosene lamps also reinforces the idea of resilience and self-sufficiency that is so important to the Amish community. By avoiding modern technologies and relying on practical and traditional solutions, the Amish can face winter without worrying about power outages or rising energy costs. In addition, oil and kerosene lamps offer a light source that, being soft and warm, contributes to the cozy atmosphere of their homes during the long winter months. strategic use of windows, and natural light. The Amish design their houses following architectural principles that seek to make the most of natural sunlight. These homes typically have large, south-facing windows, which not only allow them to capture as much light as possible during the day, but also to accumulate heat, especially during the cold months. South-facing orientation is fundamental in sustainable design because it maximizes sun exposure in winter when the sun is lower, while in summer the higher sun angle helps prevent overheating. In addition to orientation, the location and size of the windows are precisely chosen to optimize cross-ventilation, a natural cooling method that maintains a comfortable temperature without relying on electrical systems. This architectural approach, also known as passive design, aligns with the Amish self-sufficient lifestyle philosophy, minimizing the use of external resources and reducing the need for artificial heating or lighting during the day. To further improve efficiency, windows sometimes have wooden frames that act as insulators, preventing heat loss. It is also common to see deep eaves that block direct sunlight in summer, keeping houses cooler. The use of natural light is not only based on functionality and energy efficiency, but also contributes to the quality of life inside the home, creating warm and welcoming environments, ideal for domestic activities that are part of the Amish daily routine, such as sewing, weaving, and reading. All of this reflects a close connection with nature and a commitment to a sustainable and environmentally friendly lifestyle. Masonry heaters, also known as thermal mass heaters or Russian stoves, are highly efficient heating systems that use a brick, stone, or ceramic structure to store and distribute heat evenly and for an extended period. This type of heater has been used for centuries in different regions of the world, particularly in Eastern Europe, Scandinavia, and Alpine regions, due to its ability to provide a constant and comfortable heat source with minimal fuel use. These heaters work by burning wood, which produces a high amount of heat in a short period of time. Unlike a conventional stove, where the heat generated is quickly lost, masonry heaters store the heat in their thermal mass, which can be several hundred kilos of brick, stone, or refractory tiles. Once the material has absorbed the heat, it is slowly released over many hours, maintaining a pleasant temperature even after the fire has been extinguished. One of the most outstanding advantages of masonry heaters is their energy efficiency. Due to their ability to store heat, they require fewer combustion cycles and, therefore, less fuel, which contributes to lower emissions of polluting gases. These systems are also capable of providing radiant heat, which is healthier than the hot air generated by conventional systems, as it does not dry out the air or cause cold drafts. The thermal mass of these heaters is designed to make the most of heat energy and may include internal ducts that extend the path of hot gases, extracting as much heat as possible before being expelled to the outside. In addition, the design and construction of a masonry heater are usually customized, adapting to the needs of each home and the characteristics of locally available materials, which also gives them additional aesthetic value as part of the home's decor. Masonry heaters, also known as mass stoves or thermal mass heaters, are devices designed to store a large amount of heat and release it gradually over time. Their operation is based on the ability of certain high-density materials, such as bricks, stone, or concrete, to efficiently absorb heat and then radiate it slowly. This type of heater has been used for centuries in various parts of the world, especially in cold weather regions, thanks to its ability to maintain a comfortable environment with reduced fuel consumption. The operation of masonry heaters starts with an intense and relatively fast combustion in a fire chamber, generally fueled by wood. During this process, a large amount of heat is generated, which is absorbed by the thermal mass of the heater, built with materials with high heat capacity. These materials, such as refractory brick or volcanic stone, have the particularity of retaining heat and releasing it constantly for hours and even days after the fire has been extinguished. This cycle allows the interior temperature of a home to remain stable without the need for a continuous energy source, resulting in a highly efficient system. One of the main advantages of masonry heaters is their low maintenance. Because they operate through rapid and efficient combustion, the amount of waste, such as ash and creosote, is considerably less than that generated by other wood heating systems. In addition, the combustion efficiency is such that most of the gases and particles are burned within the system itself, which reduces polluting emissions. This makes them an ecological and sustainable option for home heating, especially compared to more modern systems that rely on fossil fuels. In terms of design, masonry heaters can take various forms and styles, adapting to the aesthetics of a home and acting as a central element in the space. They are often built with decorative bricks or natural stones that make them visually appealing as well as functional. Some designs include integrated heated benches, ovens for cooking, or flat surfaces for heating water, which multiplies their uses. This flexibility in design also allows these heaters to be unique pieces, custom built according to the needs and preferences of the owner. From an energy point of view, masonry heaters are very efficient due to their ability to reduce the constant use of fuel. By operating in cycles, they require fewer interventions to rekindle the fire, which in turn translates into less use of resources. This can be a significant advantage in regions where firewood can be expensive or scarce. Compared to electric or gas heaters, masonry heaters also offer a significant advantage in terms of long-term costs, since once installed, operating costs are minimal. Modern insulation techniques. Modern insulation techniques encompass a range of advanced synthetic materials like polyurethane, XPS, extruded polystyrene, and aerogels, all offering high thermal resistance. Radiant barriers that reflect heat are also commonly employed, alongside technologies like airtight sealing and spray foams to eliminate air leaks. External thermal insulation systems, ETICS, enhance efficiency by enveloping the structure with an insulating layer. High-efficiency glazing, with low emissivity coatings and inert gas, fills further contribute to thermal performance. These techniques, combined with the use of expanding foams and passive adjustments based on home automation principles, can complement traditional methods to maximize energy efficiency and sustainability in construction.